Greetings to everyone. Today we are going to discuss about the problems related to resultant stress, that is due to direct stress and due to bending stress. What is the stress is going to get it? Those problems we are going to discuss. So last class we have discussed about the derivation related to this uh, resultant stress which are related to eccentric load in a single axis. Okay, so similar to that we are going to see the problems right now. The problems are the line of thrust in a compression testing machine. In a compression testing machine, specimen, in a compression testing specimen, 15 diameter, comma, is parallel to the axis of specimen, parallel to the axis of specimen. But is displaced from it, but is displaced from it. Calculate the distance of the line of thrust. Calculate the distance of the line of thrust from the axis when the maximum stress is 20 percentage greater than the mean stress in on a normal section. So this is the given data. So the given data are, the line of thrust is nothing but axis. Okay, in a compression testing machine, specimen 15 diameter. So the dia of specimen is equal to dia of specimen D is equal to 15 is parallel to the axis of specimen but is displaced from it. So when I'm going to apply the load, it is displaced from its original position. Okay, calculate the distance of the line of thrust, that is eccentricity. Calculate the distance of the line of thrust, which is nothing but eccentricity, from the axis when the maximum stress is 20% greater than the mean stress. So maximum stress sigma max is equal to 20% greater than the. So here 1.2 times of sigma mean. Okay, sigma mean is nothing but P by A. Okay, so this is the given data. Now let us move on to the solution part. So solution. So first of all, we know that mean stress sigma mean is equal to P by A. So we need area. So what is the area? Pi by 4 into d square. So here d is equal to 15 mm. So pi by 4 into 15 square. So the area becomes 176.715 mm square. Okay, this is the area. Next, bending stress. Bending stress. Sigma B is equal to. So we all know one relation, M by I is equal to sigma B by Y. Therefore, sigma B is equal to M by I into Y. Okay. So we all know that here Y is equal to D by 2. So based on the condition, it is going to plus or minus. Okay. Now, therefore, sigma B is equal to M by I into plus or minus d by 2. Since the y is nothing but they have mentioned that circular diameter shaft. Okay. So from this, this is our y. So y is nothing but d by 2. Okay. So here we can use capital D instead of small d since we have mentioned like that. Okay. Now moment we all know that P into E. So we have to calculate the eccentricity only. I moment of inertia. Moment of inertia I is equal to pi by 64 into d power 4. So pi by 64 into d power 4. Okay, d value is 150 mm. Okay, 15 mm. So 15 square. 15 power 4 divided by 64. It becomes 2485.05 mm power 4. So this is the value of I value. Therefore, m by I into plus or minus d by 2. So d by 2 is equal to 715 divided by 2. Okay, so d by 2 becomes 7.5 mm. Okay, so next we should move on to substitution. They have given that maximum stress should be equal to 20 percentage greater than, okay, 1.2 into sigma mean. Okay, they have mentioned this is the given data. So maximum stress, we all know that direct stress plus bending stress. So 1.2 sigma mean is nothing but direct stress, that is P by A. So we have to substitute these values. So sigma naught is equal to P by A. So area, the value is 176.715. 176.715 plus sigma B is equal to M by I. So M we know that P into E, M by I. So I value we know that we have got that 2485.05 into Y. So Y is nothing but D by 2. So D is nothing but 7.5. We have known that. Then 1.2 into P by A. So P we don't know. The value of A is 176.715. So in all the term, both left side and as well as right side, the P value is common. So it is going to get cancelled. So now remaining whatever is available, based on that we have to calculate the value of eccentricity. So 1 divided by 176.715. is equal to 5.659 into 10 to the power 3 minus 3 plus 7.5 divided by 2485.05 becomes E divided by 3.018 into 10 to the power minus 3 is equal to 1.2 divided by 176.715. So 6.791 into 10 to the power minus 3. Therefore, E divided by 3.018 into 10 to the power minus 3 is equal to 6.791 into 10 to the power minus 3 minus 5.659 into 10 to the power minus 3. So minus 5.659 exponential to the power minus 3 becomes 1.132 into 10 to the power minus 3. So this is the E divided by 3.018 into 10 to the power minus 3. Okay. So therefore E becomes, so 1.132 exponential to the power minus 3 into 3.018 exponential to the power minus 3. So instead of this, we can do like this. Okay. So 1 divided by 176.715 plus 755 times of E divided by 2485.05 is equal to 1.2 divided by 176.715. So if I am going to, this term is going to right hand side. So 7.5 times of E divided by 2485.05 is equal to 1.2 divided by 176.715 minus 1 divided by 176.715. So the term becomes 755 times of E divided by 2485.05 is equal to 0.2. That is, here the common term is 1 divided by 176.715 is the common term. So if I am going to take it outside, it becomes 1.2 minus 1. So 1.2 minus 1 becomes 0.2. Okay. So 0.2 divided by 176.715. Now E becomes, so 0.2 divided by 176.715 multiplied with 2485.05 divided by 7.5. Therefore, E is equal to how much? So 0.2 into 2485.05 divided by 176.715 into 7.5. It becomes 0.375 mm. Okay, so this is the value of eccentricity. So next we should move on to the another problem. That is problem number 3. That is, here we have seen that circular section, solid circular section we have seen. Okay, so next we should go for hollow, square or rectangular section. Okay, from that next to what is the stress that we are going to find out. Okay, the problem is a hollow rectangular section, sorry, column of external depth of external depth 1 meter and external width external width zero point 0.8 meter is 10 centimeter thick. Calculate the maximum and minimum stress. Calculate the maximum and minimum stress in the section of the column. If a vertical load of if a vertical load of 200 kilonewton is acting with an eccentricity of 15 centimeter as shown in figure. So here the column section is available. So this is the axis, and they have mentioned that this is the depth. D is equal to, capital D is equal to 1000 mm. That is 1 meter equal to 1000 mm. And the thickness 10 centimeter. So 100 mm thick. Similarly, the breadth of the section B is equal to 800 mm external. Okay. So here the load has been applied somewhere here. Okay. So it is going to be at here. The load P is going to be at here. That value of P is equal to 200 kilonewton with an eccentricity of 150 mm. Okay, so these are all the given data. So first given data is equal to capital B is equal to 800 mm. Similarly, capital D is equal to 1000 mm. So thickness T is equal to 100 mm. So if I am going to deduct this thickness, I can get the inner breadth. So 800 minus 2 times of 100 becomes 600 mm. Similarly, small d is equal to 1000 minus 2 times of 100 mm thickness. So it becomes 800 mm. Then along with that, the load and the eccentricity we can have. So load P is equal to 200 kilonewton. That is equal to 200 into 10 cube newton. And eccentricity is equal to 15 centimeter they have given, which is nothing but 150 mm. So these are all the given data. Now let us move on to the solution part. So first of all, we need area. So area is equal to capital B into D minus small b into D. Since we need only we have to deduct the hollow portion, okay? So 800 into 1000 minus 600 into 800. So 800 into 1000 minus 600 into 800. So it becomes 320 into 10 cube square. So area EA is equal to, next to moment of inertia. Moment of inertia about y axis. Since the load is acting on the eccentricity with respect to the x-axis, so we have to get the y-axis moment of inertia. So Iyy is equal to b cube d by, since it is a hollow section, so b cube d by 12 minus b cube d by 12. So 800 cube into 1000 divided by 12 minus 600 cube into 800 divided by 12. Therefore, Iyy becomes 800 cube into 1000 divided by 12 minus 600 cube minus 600 cube into 800 divided by 12. The answer is 2.8 2.827 into 10 to the power 10 power 4. So this is the value of Iyy. Now we all know that the moment m is equal to P into E. So what they have asked, we have to calculate the maximum and minimum stress. Okay. So for maximum stress, we all know that sigma max, okay, is equal to direct stress plus bending stress. Okay. So direct stress plus bending stress. We all know that for sigma minimum, direct stress minus bending stress. Okay. So for direct stress, sigma naught is equal to P by A. For bending stress, sigma B is equal to M by I into Y. Okay. So for Y value here, the total section is with respect to breadth, the total breadth is equal to B by 2. Okay. So Y is equal to B by 2. So total breadth is 800 divided by 2. So it becomes 400 Okay. Next, we should move on to the M value and Y value, I value. Okay, I we have calculated already. So M. So M is equal to P into E. So what is the value of P? 200 into 10 cube is the P value. And the E value they have given as 150 eccentricity. So 200 into 10 cube into 150 becomes 30 into 10 to the power 6 Newton So now we have to substitute these values into sigma max and sigma minimum formula. Okay. So sigma max is equal to P by A. So 200 into 10 cube divided by area. So area value is 320 into 10 to the power 3. 320 into 10 to the power 3 plus m by I. So m value is equal to 30 into 10 to the power 6 divided by I value. I value is 2.827 into 10 to the power 10. 2.827 into 10 to the power 10 into y value 400. So this is the value for sigma max. Similarly, sigma minimum is equal to 200 into 10 cube. That is P by A minus M by I. Okay. So minus 30 into 10 to the power 6 divided by 2.827 into 10 to the power 10 into 400. Okay. Now we can calculate the values. Okay. 200 into 10 cube divided by 320 into 10 cube plus 2.827 exponential power 10. So 1.049 Newton per mm square. So this is the value is in positive, so which denote that compressive stress. Compressive stress. Next one is sigma minimum. So 0, if I'm going to substitute these values, I can get 0.200 Newton per mm square. So this is also in positive. So this stress is also becomes compressive stress. Now I have to draw the stress distribution diagram. So this is the neutral axis line. So here it is positive and here also it is positive. Okay, now at the end, okay, column end. So both are in positive. So we have to, so 1.049 Newton per mm square maximum stress. Similarly, minimum stress is equal to 0.200 Newton per mm square. So this is the stress distribution diagram. So up to this problem is over. Next, we should move on to the problem related to hollow circular section. So the given data. A short column of a short column of external diameter 40 centimeter. So they have given that external dia capital D is equal to 40 centimeter and internal diameter is 20 centimeter. So internal diameter is equal to 20 centimeter. Carries an eccentric load of carries an eccentric load of 80 kilonewton. So P is equal to 80 kilonewton. Find the greatest eccentricity. Greatest eccentricity which the load can have without producing tension on the cross section. So this is our first question. Next, the second question is the same if, so first the greatest eccentricity E we have to calculate for the first question. Okay, when we have to calculate without producing the tension, which means sigma minimum value is equal to 0, means what is the eccentricity that we have to calculate. Our second question is if the eccentricity is 150 mm, then what is the value of sigma max and sigma minimum? So this value we have to calculate. Okay, so there are two questions in this given problem. So based on that, we have to calculate the eccentricity and everything. So to find, okay, if sigma minimum is equal to 0, then what is the value of E? And second question, if E value equal to 150 mm, then what is the value of sigma max and sigma minimum? So this is our questions. So let us move on to the problem solution. So for the first question, okay, if sigma minimum is equal to no tension force, that is 0, then what is the value of E? Okay, so we all know that sigma minimum is equal to direct stress sigma naught minus sigma b, bending stress. So sigma naught is equal to P by A. Okay. Similarly, sigma b is equal to m by I into y. Okay. So now we have to calculate these values. So P value they have given us 80 into 10 cube. Okay. Similarly, area we have to calculate. So area, this is hollow circular section. So pi by 4 into capital D squared minus small d squared is the formula. So 80 into 10 cube divided by 4 into capital D is 40 centimeter and small d is 20 centimeter. So 400 mm and 200 mm. Okay. So 400 squared minus 200 square. So if I'm going to substitute this value, I can get the value of sigma naught, that is direct stress. So 80 into 10 cube divided by pi by 4 into 400 square minus 200 square. If I'm going to substitute this, I can get the value of P by A is equal to 0.849 Newton per mm square. Now the sigma B, bending stress, which is nothing but moment is equal to P into E, eccentricity. Okay, so we have to calculate the eccentricity value for the first condition. Okay, so let us keep as it is. So P is equal to 80 into 10 cube E. Okay, I value is pi by 64 into d power 4 minus small d power 4. So the value becomes 400 power 4 minus 200 power 4. So set to pi by 64 into 400 power 4 minus 200 power 4. 1.178 into 10 to the power 9 mm power 4. So this is the value of I value. Now y is equal to capital D by 2 since it is a hollow circular section. Okay, it is a hollow circular section. Okay, from the neutral axis, what is the value of extreme fiber distance? That is nothing but y, that is equal to D by 2. So if I'm going to put this, I can get 200 mm is my y value. So next, sigma b is equal to m value. So 80 into 10 cube E, 80 into 10 cube E divided by I value 1.178 into 10 to the power 9 into y value is 200 mm. So if I'm going to substitute the E value, the sigma B value, we can get it in terms of E. So 80 into 10 cube into 200 divided by 1.178 exponential power 9 into 10 to the power 9. So if I'm going to substitute these values, I can get 0.0136 into E. Okay, sigma B becomes. Therefore, sigma minimum is equal to 0. We all know that. So, sigma minimum value is P by A minus M by I into Y. So, which is nothing but sigma naught minus sigma B is equal to 0. So, sigma naught value is 0.849. So 0.849 minus 0.0136 into E is equal to 0. Therefore, E becomes 0.849 divided by 0.0136. So 0.835 mm we are getting. So if we are going to substitute these values, okay, so it becomes minus 0.849, okay, now, so minus minus gets cancelled. So 849 divided by 0.0136. If we are going to substitute these values, we can get E value is 62.43 mm. So if the tensile stress sigma minimum is equal to 0, then the value of eccentricity is 62.43 mm for the eccentric load of 80 kilonewton. Okay. Next, the second question is available. So the second question is, if the eccentricity is 150 mm, then what is the value of sigma max and sigma minimum? Okay. So we should move on to the second question. If eccentricity is equal to 150 mm, then sigma max is equal to how much? Sigma minimum is equal to how much? That we have to calculate. So sigma max is equal to P by A, that is direct stress plus bending stress. Okay. Similarly, sigma minimum is equal to direct stress minus bending stress. So, which is nothing but P by A plus M by I into Y. Okay. Here it is P by A minus M by I into Y. So P by A value is nothing but earlier we have calculated, that is 0.849 Newton per mm square. So we have to take same value 0.849 Newton per mm square. Similarly, M by I into Y. So that value becomes 0.0136 E. 0. Sigma B is equal to 0.0136 times of E. Okay, substitute E value. So 0.0136 into 150 mm. It becomes 2.04. So 2.04 Newton per mm square. Therefore, sigma max is equal to, what is the value? 0.849 plus 2.04. If I'm going to add these two values, I can get 2.889 Newton per mm square. So this is in positive. So this value is denotes compressive stress. Now, sigma naught, that is P by value is 0.849 minus sigma B 2.04. So it becomes minus 1.191 Newton per mm square. So minus sign denotes the tensile stress. So we have to write 1.199 tensile stress. So this is the answer. Now for the diagram, okay. So for the sigma max is equal to 2.889 Newton per mm square. Similarly, sigma minimum is equal to minus 1.191, okay, 1.191 Newton per mm square. So this is our stress distribution diagram. For the given hollow circular section. Thank you all.